Yes, very good evening to all. Yes. Hello, Kiran Akhtar. Very good evening to all. Check your audio and video settings. Now I start the session. Okay. See here. So in the previous session, we clearly discussed about what is Java, what is the purpose of Java. Just a minute. Okay. So in the previous class, we clearly discussed about what is Java, what is the purpose of Java, what are the parts of Java. So what is Java? Java is a language. It is a programming language. Okay, so it is the general purpose high level object oriented programming language. When Java was introduced officially, it was announced in the 1995, but Java's first version released in 1996. So who is the father of Java? James Gosling is the father of Java. He played major role, lead role in the development of Java. James Gosling and his team developed this Java language. So this Java, initially it was the product of Sun Microsystems. Later, Sun Microsystems was undertaken by the Oracle company. So Oracle company purchased Sun Microsystems company in the 2010. In the 2010, so now Java is the product of Oracle company. So this Java is the general purpose because using Java we can develop many kinds of applications like standalone, web applications, and mobile applications. Standalone applications means the applications developed to run in one computer, like Notepad, Calculator, MS Office, media players, Photoshop, Acrobat Reader. All these are examples for standalone applications. If we want to edit the photos, we must install Photoshop in the system. If we want to watch the movies, we must install media player software. Okay. So this software developed to run in one computer on one machine. Such type of applications are called standalone applications. Web applications means the application will be published in remote system, but that application can be used by many clients with the help of browser and network. Web applications means just like websites. Websites are published in the server. We are the clients from our machine. We are accessing them. That may be smartphone, that may be tab, or that may be computer. We're accessing those web pages. So such type of web applications we can develop by using Java, and we can develop mobile applications also. But nowadays we are not using Java for mobile applications. Okay, so we can use Java for mobile applications, web applications, and standalone applications. And this Java is the high level programming language, means it is suitable to develop the application software. It is not suitable to develop the system software like operating system, compiler, interpreter, device driver. These are comes under system software. These are the examples of system software. We cannot develop this type of system software by using Java, but we can develop application softwares like hospital management softwares, college management softwares, university management softwares, shopping mall management softwares, restaurant management software. Such type of application softwares we can use. Banking management softwares. So that's why we are calling Java as the high level programming language. So it is a general purpose programming language because we can develop many kinds of applications. It is a high level programming language because it is suitable to develop the application software. It is programmer friendly. Okay, and it is the object oriented programming language because it supports two object oriented programming concepts, like encapsulation, abstraction, inheritance, and polymorphism. So according to the Sun Microsystems, Java has three parts. Java has three parts. Those are Java SE, Java EE, and Java ME. SE stands for Standard Edition, EE stands for Enterprise Edition, ME stands for Micro Edition. Okay, so for our core Java, we use Java SE version, Java SE. So we have to download this Java SE from the Oracle website. So in the Java SE, we write the programs. Okay, so till here we discussed in the previous session. Now, listen. Now I want to talk about what are the in today's session. I want to talk about what are the features of Java. So what are the major features of Java? What are the major features of Java? Okay, so I'm discussing some important features. Like, say, what are the features? Listen, first one is this Java is the platform independent. Listen carefully. This Java is the first I read the list. After that, I will explain each and every feature clearly. Listen. So this Java is the platform independent programming language. So Java is the platform independent programming language, and it is the mission independent programming language. Java is the mission independent programming language, and it is both compiled and interpreted programming language. Java is the interpreted compiled and interpreted programming language. This Java is the pure object oriented programming language. Pure object oriented programming language. It is the robust programming language. Okay, it is the secured programming language. It is the dynamic programming language. It is the simple and familiar programming language. It is the distributed programming language. It is the multi-threaded programming language. It provides high performance. So these are the major features of Java. And this Java is the portable programming language. It is a portable. It is a portable programming language. So these are the features. So total 12 features I have written here. So I will explain each and every feature one by one. Listen carefully here. So what is the first feature here? It is a platform independent. Java is a platform independent programming language. It is a mission independent programming language. It is a compiled and interpreted programming language. It is a pure object oriented programming language. It is a portable programming language, robust programming language. It is a secured programming language. It is a dynamic programming language. It is a simple and familiar programming language. It is a distributed programming language. It is a multi-threaded programming language, and it provides high performance. So these are the features. So among these, first one is platform independent. Now I'm explaining about platform independent programming language. Okay. So platform independent programming language. Java is the platform independent programming language. So here, what is platform? Platform means what? Listen carefully here. Platform means operating system, operating system plus microprocessor. Combination of operating system and microprocessor. Operating system and microprocessor is called platform. So platform means operating system plus microprocessor. Remember one point. So you already know. See, you already know the operating systems like Windows is the operating system. Okay, Linux is the operating system. Linux. Unix is the operating system. Linux, Unix, Windows. Okay, Mac operating system, Macintosh. Okay, all these are the operating systems. So you already know the microprocessors. What are the examples for microprocessor? Like Intel microprocessor, AMD microprocessor. Okay, Celeron microprocessor. These are the examples for microprocessors. Remember one point, listen carefully. Every operating system has its own language. Every operating system has its own language, and every microprocessor has its own language. Okay, so the language which can be understood by the Windows may not be understood by the Linux or Unix or Mac. The language which can be understood by the Linux may not be understood by the Windows or Unix or Mac. So like this, every operating system has its own language. The instructions which can be understood by one operating system may not be understood by another operating system. So like that, for the microprocessors also, every microprocessor has its own language. The instructions which can be understood by Intel, the language which can be understood by Intel may not be understood by AMD or Celeron. The language which can be understood by the Celeron may not be understood by the Intel or AMD. So like that, each and every operating system has its own language. Each and every microprocessor has its own language. Remember this one. Okay, now see what is platform independency. Platform independency means, so to understand this, I will explain the execution process of a C program and Java program. Pay attention and listen carefully here. Now, for example, I am writing a C program here. I'm writing a C program. So this is a C program. I'm storing in one particular file. I'm storing this in one particular file. I am giving file name as hello. I am giving file name as hello, hello.c. This is the C file. So this code we are writing. So this code I'm calling as source code. The code which we are writing is called source code. The code which we are writing in the program is called source code. So this is the program we saved in particular file. That file name is hello.c. Now this program source code is in a high level language. The source code is in high level language. Computer cannot understand this. Our language is high level language. Computer language is low level language. So computer cannot understand this high level language code. So we have to translate it to the low level language. So for that, what we do, we have to compile. We have to compile this program. So we compile this program. After compilation, it will generate exe file. After compilation, it will generate exe file. .exe file will be created. Okay. So file name is hello. Hello.exe file is created. Then what this exe file contains? This exe file contains machine code. Exe stands for executable. This is executable file. This exe file contains machine code. Exe file contains machine code, or you can say native code or machine code, which can be understood by the operating system. So this is operating system's language. Native code is the operating system's language, or you can say machine code. Machine code is the operating system's language. Operating system can understand this. The code which is the code which is in the exe file can be understood by the operating system. So that code we are calling as machine code, or we can say native code. So this is the execution process of a C program. This is the execution process of a C program. Now listen carefully. Now I'm showing the execution process of uh, Java program. I'm showing the execution process of Java program. Observe carefully here. So here I'm writing a program. This is the Java program. Okay, I'm saving this with the name hello.java. So this is the source code. We are writing some code. That code is called source code. So this code is in high level language. I want to compile this program now. So after compilation, now we are compiling this Java program. So to compile the Java program, generally we use the command Java C command, Java compiler. So after compilation, it will generate a file. That file contains code. That code is called bytecode. That code is called bytecode. Bytecode file will be generated. And for the bytecode file, that gives main method's class name as the file name. Assume that main method's class name is also hello. So with hello dot class, now hello dot class file will be created. Okay, now who can understand this bytecode? Only JVM can understand this one. Okay, so only JVM can understand this one. So to run this bytecode, we use the command Java, means JVM will be started. JVM stands for Java Virtual Machine. This is one special software used to run the Java applications. To run the Java applications, we use one special software that is called JVM. JVM stands for Java Virtual Machine. When we use Java command, this JVM will be started. The JVM translates bytecode to the machine code. JVM translates bytecode to machine code, or you can say this as the native code. This is the exe file. This exe file will be created. Okay, so this code can be understood by the operating system. So operating system displays output to us. Here also same, this code can be understood by the operating system. So operating system displays output to us. So this is the execution process of, so this one is the execution process of a C program. This one is the execution process of a Java program. Once again, I am repeating. Pay attention and listen carefully here. So here we are writing a C program. This code is called source code. I am storing in one particular file. That file name is hello. Hello.c is the extension of C program. Hello.c. So this program is in high level language. Computer cannot understand it. So I'm compiling this program. After compilation, what it is creating? Exe file. So exe file will be created. So this exe file contains what? Machine code. Exe file contains machine code, or you can say native code, which can be understood by the operating system. So operating system runs this exe file and displays output to us. This is the execution process of C program. Okay, what is the execution process of Java program? Here we are writing Java program. This code is called source code. So we compile this program by using Java C command. After compilation, it will create the bytecode. It will generate bytecode. Okay, so this no one can understand this bytecode. This bytecode is secured. No one can understand it except JVM. Only JVM can understand this code. So to run the JVM, to start the JVM, we use Java command. What is JVM? JVM stands for Java Virtual Machine. It is one special software. JVM is the software used to run the Java applications. Only JVM can understand bytecode. So JVM is used to run this Java application now. So they translate this bytecode to the machine code. So this machine code can be understood by the operating system. So operating system displays output to us. So this is the execution process of C program. This is the execution process of Java program. So if you observe these two diagrams, after C program compilation, it is generating exe file. After Java program compilation, it is not generating exe file directly. It is generating one intermediate code. That intermediate code is called bytecode. So because of this intermediate code, because of this bytecode, Java became platform independent. In the programming languages like C, C++, after compilation, that generates exe file directly. So that's why those are called platform dependent programming languages. Whereas in case of Java or Python or C sharp, these are called platform independent programming languages, because after compilation, they will not generate exe file directly. They will generate intermediate code. In the Java, we are calling this as the bytecode. In the Python also, we call it as the bytecode. In the C sharp, we call this as the IL code, intermediate language code. Okay, so like that. So in the platform independent programming languages, after compilation, intermediate code will be generated. In the Java, we call it as bytecode. So to run this intermediate code, one special software is required. For Java, we are using JVM. For Python, we are using PVM, Python Virtual Machine. For Java, we are using JVM, Java Virtual Machine. Okay. So This special software converts this byte code to the machine code according to the operating system and microprocessor. Okay, now I want to explain more about this platform independency. Now you know the execution process of C program and execution process of Java program. Now listen carefully here. Okay, now same two cases I'm taking. Observe. So this is the C program. This is the C program written in one computer. So this is one computer written in one computer. This computer has Windows operating system. Windows 10 operating system is there. So Windows 10 operating system is there in the system. So after compilation, it will generate machine code according to the Windows 10 and according to the microprocessor. So now this code can be understood by the Windows 10 operating system only. For example, this is another computer. Observe here. This is another computer. This is another computer. In this computer, I want to run this C program. So now this computer has also same operating system, Windows 10. So now I'm placing this hello.exe file here, hello.exe file in the system. Can we run this exe file? Yes, we can run, because this exe file has Windows 10 machine code. Windows 10 machine code can be understood by Windows 10. So we can run. For example, here another system is there. This is another system. This has Linux operating system. This is another system. This system has Unix operating system. Now I want to run this hello.exe file in this system which has Linux. And I want to run this hello.exe file in the system which has Unix. Now can we run here? No. Can we run in the Unix? No, because this hello.exe file has Windows 10 machine code. Windows 10 machine code cannot be understood by Linux. Windows 10 machine code cannot be understood by Unix. So you cannot run this hello.exe file here, and here also you cannot run. So if same operating system is there, you can run that exe file. If different operating system is there, you cannot run that exe file, because exe file contains a machine code. There is operating system's language. So that's why we are calling C language is the platform dependent. C language is the platform dependent. It is depending on operating system. So if same operating system is there, then only we can run the exe file. If different operating system is there, we cannot run. After compilation, it is generating exe file. That exe file contains machine code according to the operating system installed in that system. So every operating system has its own language. The language which can be understood by Windows may not be understood by Linux or Unix or Mac. I already told. So Windows 10's language cannot be understood by the Linux and Unix. So that's why you cannot run this exe file in another system which has different operating system. If same operating system is there, you can run, no problem. But if different operating system is there, you cannot run. So this is, so that's why we are calling C as the platform dependent. That's depending on operating system. Whereas in case of Java, after compilation, what it is generating? Bytecode, not exe file. So I want to run. See, now this is one computer. Assume that this is one computer. This is one computer. This computer has Windows operating system, Windows 10. So here Windows 10 machine code is there. Now observe carefully. This is another system. This is another system. This system has Unix operating system. This is another system. This is another system. This has Linux operating system. Okay, now I want to run this Java application in this system which has Unix. So simply take this bytecode file and place here. Take the bytecode file. What is the bytecode file name? Hello.class. So place hello.class file here. Bytecode file. Okay. Now to run this bytecode, JVM is required. So install JVM software in this system. Now that JVM translates this bytecode to the machine code. Now that generates Unix machine code here. So Unix machine code will be generated. So this is the exe file, hello.exe file. So Unix machine code can be understood by the Unix. So you can run here. Now same Java application I want to run in the Linux. So simply take this bytecode file again. Again I'm taking bytecode file only. Okay, hello.class. But to run this bytecode file, JVM is required. So install JVM. So the JVM translates this bytecode to the machine code. Machine code will be generated now. According to which operating system? According to the Linux. So now can we run here? Yes, we can run. So who is responsible to run Java application? JVM, not operating system. Whereas in case of C, C++, operating system is responsible to run the Java, run the C, C++ programs. Operating system is responsible to run the C, C++ programs. After compilation, that is generating exe file directly here. So operating system runs that one. Whereas in case of Java, after compilation, it is generating the bytecode. Who is responsible to run this bytecode? JVM is responsible. So JVM translates bytecode to the machine code according to the operating system installed in that computer. So even if operating system is same, we follow same steps. So for example, this is another system. This has also Windows 10. Now also take this bytecode file and place here. After compilation, it will generate exe file. This exe file contains Windows 10 machine code. But to run this, JVM is required. So JVM translates this bytecode to the machine code according to the Windows 10. Now we can run here. So this Java application, this bytecode, Java's bytecode is not depending on operating system. So this Java application is not depending on operating system. Who is running this bytecode? JVM is running, not operating system. So that's why we are calling Java as the platform independent. So Java, Python, C Sharp, these languages after compilation, they will generate intermediate code. Java generates bytecode. So because of this intermediate code, because of this bytecode, Java became platform independent. We placed the bytecode file. Who is responsible to run bytecode file? JVM. So JVM translates bytecode to the machine code according to the operating system installed in that machine. Okay. So that's why Java became platform independent. But remember, this JVM is the platform dependent. JVM is depending on operating system. But Java application, Java's bytecode is not depending on operating system. Java's bytecode is platform independent. But JVM is platform dependent. JVM is depending on operating system. Okay. So because of this bytecode, because of this intermediate code, Java became platform independent. That's it. So that's why we are calling Java as the platform independent programming language. So once upon a time, this feature was not there. Before Java, this feature was not there. Okay. So at that time, we were using when Java was introduced. At that time, we were using C language, C++ language, and later VB language was also there. So those languages were same when Java was introduced. All those languages were platform dependent only. So if we develop one software and we give it to the client, okay, client must use same operating systems. Client must use same operating systems to run that application. That was the problem at that time. But when Java came with a new feature, when Java was introduced, it came with a new feature, platform independency. After compilation, it generates a bytecode, not machine code. So because of this bytecode, Java became platform independent. That's it. Okay. So all the platform independent programming languages like Java, Python, C Sharp, after compilation, they generate intermediate code. Because of that intermediate code, they became platform independent. Whereas C, C++, after compilation, they generate machine code. So that's why they are platform dependent. And next feature is what? Next feature is machine independent programming language. I'm calling Java as the machine independent programming language. So this Java is the machine independent programming language. Machine independent programming language means, see, you already know about C, C++. So this C, the applications developed in C, C++. The applications developed in the applications developed in C or C++ can run on computer only. Can run on computer only. Okay, nowadays for mobile applications we are using C++. So Microsoft is providing that feature. But once upon a time that feature was also not there. So the applications developed in C++ can run on computer only. We cannot run on many machines. We cannot run on many machines. We cannot run on many machines. What are those many machines? Like I want to run our Java application on router. So in the router also some software is there. Okay, and in the remote control also some software is there. In the setup box also, in the setup box also some software is there. In the setup box also some software is there. Okay, so like this in the smartphone, in the tab, I want to run my application in the router or in the remote control or in the setup box or in the smartphone or tab. So this is not possible if the software developed by using C++, because the software developed by using C++ can run on computer only. We cannot run on many devices. So that's why C++ are called mission dependent. They are mission dependent. So whereas Java is the mission independent. So Java is mission independent. So the application developed, the software developed using Java, the software developed using Java can run on many machines, can run on many machines, not only computer, can run on many machines, not only computer, but also we can run on router. So in the routers, we can run our Java application. Okay, in the setup boxes, we can run our Java applications. Okay, in the smartphone, we can run our Java application. Okay, in the tab, we can run our Java application. In the personal digital assistant, PDA, or you can say palm top computer to generate electricity bill. Okay, to generate the bills we use generally. Okay, PDS, personal digital assistants. Okay, so in such type of devices, so like this Java application can run on billions of devices. Whenever you are installing the Java, that displays to you Java supports to uh, 3 billions of devices, like that. The ATM machines, you can use it. The smart cards, you can use it. So like this Java application we can run on many machines. So that's why we are calling this as the mission independent. So just now we discussed two features. One is platform independency, another one is mission independency. So these two features brought so many changes in the software industry. When Java was introduced in the 1995, okay, now we are in 2020. We are in 2020. Now also we are using Java. So from the last 20 to 25 years, Java is ruling the software industry because of these reasons, because of platform independency and because of mission independency only. This Java is ruling the software industry. So before Java, these features were not there. This Java brought these new features. Okay, so that's why this language brought so many changes in the software industry. So these two are the very important features, major features of the Java. Before Java, these features were not available. So actually, Sun Microsystems got a project from another company. Okay, that is one electronic devices company. They wanted to run that application on many electronic devices, on many machines. So from that client requirement only, the Sun Microsystems developed this Java language. Then they developed software. Okay, so this Java is a platform independent programming language. We can run Java application on any operating system. Just simply take the bytecode file and you can run. But to run the Java application, JVM is required. JVM is the platform dependent. Java application is a platform independent. JVM is the platform dependent. Java application is the platform independent. And next one is machine independent. Means we can run Java application on many machines. What are those many machines? These are the many machines. Okay. Next feature is this Java is both compiled and interpreted programming language. This Java is both compiled and interpreted programming language. Listen carefully here. So when Java was introduced, when Java was introduced, Java was interpreted programming language. When Java was introduced at that time, when Java was introduced at that time, Java was interpreted programming language. Java was interpreted programming language. So only interpreter was there. Okay. To run the Java application, we use what JVM. You already know it. So JVM stands for Java Virtual Machine. JVM stands for Java Virtual Machine. It is a software. It is a special software. It is a software used to run Java applications. To run Java applications, we use this software. So this JVM has execution engine. JVM has execution engine. JVM has execution engine to run the Java programs. So initially this JVM has only interpreter was there. Initially JVM execution engine has only interpreter was there. Only interpreter was there in the JVM's execution engine. So JVM has execution engine to run the Java application. So this execution engine has interpreter. Initially only interpreter was there. So to improve the performance in Java 3 version, in Java 3 version, in Java 3 version, in Java 1.3 version, they added, Java developers added, in Java 3 version, they added a compiler. That compiler is called JIT compiler. JIT compiler. JIT stands for just in time. JIT stands for just in time. Just in time. This is the name. Just in time compiler. So they added JIT compiler to the JVM's execution engine. Now JVM execution engine has interpreter plus JIT compiler. Both are there. Okay. So now JVM's execution engine has both interpreter and JIT compiler. Okay. So JVM has execution engine. JVM has execution engine. That execution engine has interpreter as well as JIT compiler. So JIT compiler added in the Java 3 version to improve the performance of the Java application. So to improve the performance of the Java application, they added this JIT compiler. So added JIT compiler to improve performance of Java application. So some statements get executed faster. Some statements get executed faster by the interpreter. Some statements get executed faster by the compiler. If single statements are there, interpreter works faster. If single statements are there, interpreter works faster. If loops or recursions are there, JIT compiler works faster. So if loops are there or recursions are there in such type of situations, compiler works faster. If single statements are there, interpreter works faster. So sometimes interpreter works faster, sometimes JIT compiler works faster. So when it executes a Java application, so that code will be distributed between the interpreter and compiler. Some code will be executed by the interpreter, some code will be executed by the compiler. Okay. So that's why we are calling this Java as the both compiled and interpreted programming language. Java is the compiled and interpreted programming language. This is another feature. And next feature is this Java is the pure object oriented programming language. I'm calling this Java as the pure object oriented programming language. Listen carefully here. Java is the pure object oriented programming language. So you already know C++. C++ is object oriented programming language, and Java is also object oriented programming language. Okay. In the previous class, I already told if any language that supports to encapsulation, I'm writing those terms here. If any language that supports to encapsulation, abstraction, inheritance, and polymorphism, if any language that supports to these four concepts, that language is called object oriented programming language. C++ supports to these four concepts, and Java also supports to These four concepts. But we are calling this C++ is not pure object oriented programming language. Not pure object oriented programming language. Okay, whereas this Java is the pure object oriented programming language. Java is pure object oriented programming language. So C++ is not pure object oriented programming language, whereas Java is the pure object oriented programming language. So why it is the pure object oriented? Why C++ is not pure object oriented? Because in the C++, see here, I'm writing one C++ program like this: class, student. Okay, starting point of class, ending point of class. So in the class, we define private sections, public sections. In that, we define properties and methods. Okay, so finally we create object. Finally, we create object for this class. So to create the object, we define main method outside of the class. So outside of the class, here we create the object. So student S1, S1 is the object now. So class means nothing but we are creating our own data type here. Like int data type, float data type, char data type. Here we are creating our own data type, student. So for this student data type, I am creating one variable that is called object. S1 is the object now. So here we are defining main outside of the class. Observe. Now main is not member of the class. We are defining main outside of the class. So outside of the class, if you want to define any members, we can define. And above of this class, if you want to declare any variables like this, you can declare the variables. This is called global declaration. And if you want to define any functions outside of this class like this, you can define the functions. So outside of the class also, you can define the members here. Outside of the class also, we can define the members. So C++ is the advanced language of C language. So all the features of C are also available for C++. So we can define functions like this outside of the class. We can declare the global variables like this. So this X is the member, I'm defining outside of the class. F1 is the member, I'm defining outside of the class. Main is the member, I'm defining outside of the class. Some members we are defining outside of the class. So that's as per object oriented programming standards. So actually first they introduced object oriented programming concepts. First they defined some rules. In the late 1950s, they introduced some object oriented programming concepts. These are introduced by MIT, Massachusetts Institute of Technology, MIT, that is one private university. Massachusetts Institute of Technology, that is one private university, private research institute, introduced this OOPS concepts in the 1950s. Later in the 1960s, first object oriented programming language was developed. That language was Simula language. Later in the 1983, in the 1980s, C++ language was introduced. So based on these OOPS concepts, they developed Simula language. So based on this Simula language, they developed this C++ language. So based on the OOPS concepts only. Okay. So later C++ has some drawbacks, like it is platform dependent, machine dependent. So they introduced another language, Java. So Java is the object oriented programming language. Like Python is the object oriented programming language. C# is the object oriented programming language. So first they introduced OOPS concepts. Based on the concepts, these languages are developed. So according to the OOPS concepts, according to the standards of OOPS, each and every member, each and every member, each and every member should be defined. Each and every member should be defined inside of class. Each and every member should be defined inside of class. Okay. So according to object oriented programming system standards, each and every member should be defined inside of the class. But C++ is not following this one. We are defining F1 member outside of the class. We are defining main outside of the class. We are defining global variables outside of the class. So we can define the members outside of the class. So that's why it is not pure object oriented. Whereas in Java, we define each and every member inside of the class. We define each and every member. We define each and every member inside of the class. We define each and every member inside of the class. So it is following this object oriented programming standard rule. So that's why we are calling this Java as the pure object oriented. So because of this reason, we are calling Java as the pure object oriented, because we define each and every member inside of the class, including main method. This main method also we write inside of the class only. Each and every variable we declared inside of the class only. Each and every method we define inside of the class only. So that's why we are calling Java as the pure object oriented programming language. And the next feature is portable. Next feature is portable. Okay. So next feature is portable programming language. I'm calling this Java is the portable programming language. Java is the portable programming language. So it is the result of platform independency, platform independency, and mission independency. So this portability is the result of platform independency and mission independency. So what is the general meaning of portable? Portable means easily we can move from one place to another. TV is portable, laptop is portable, easily we can carry, easily we can move. So similarly, Java application we can carry from one place to another, from one machine to another machine. Okay. So I already told platform independency means Java application we can run on any operating system. Machine independency means Java application we can run on any machine, like router, setup box, okay, smartphone. Okay. So because of these two reasons, this Java became portable. So portable means without making any changes, without making any changes to Java application, without making any changes to Java application, we can run on, we can run on any machine, on any machine, and on any platform. Platform means on any operating system or any microprocessor. Platform means combination of operating system and microprocessor. On any operating system, on any microprocessor, or any machine, without making the changes, we can run. So this feature is called portability. You already know that port feature is there for mobile number. For example, assume that you are Airtel customer. Assume that you are Airtel customer. You want to convert to the Geo. Okay, so without changing your number, you can become the customer of Geo. So for that, you use the feature port feature. So your number will not be changed. Number will be same, but you will get the services of Geo. That is port feature. So similarly here also same. Without making any changes, without making any changes to the Java application, we can run that Java application on any machine, on any platform. That feature is called portable feature. Okay. So next feature is what? This is the robust. Java is the robust programming language. Robust means strong. Java is the robust programming language. I'm calling this Java as the robust programming language. So robust means strong. Robust means strong. It is the strong programming language. Okay. So Java checks compile time errors as well as runtime errors. So Java checks compile time errors and runtime errors. So because of two reasons, we, we can call Java as the robust programming language. So what are those two reasons? So because of its memory management, because of its memory management, and because of exception handling feature, because of exception handling feature, because of these two reasons, we are calling Java as the robust programming language. So automatic memory management feature is there. Automatic memory management feature is there for the Java. Automatic memory management feature is there for Java. And Java supports to exception handling concept. Because of these two reasons, we are calling Java as the strong programming language. Okay, in C++, we are the programmers. We are responsible to allocate and deallocate the memory. In the C language, we use the functions like malloc function, calloc, realloc functions to allocate the memory. To deallocate the memory, we use free function in the C. In the C++, to allocate the memory, we use new operator. To destroy the memory, we use delete operator. We must destroy the memory if we allocate the memory using new. We are responsible to deallocate the memory there. Whereas in Java, automatic memory management is there. Unwanted objects will be removed by the garbage collector. So this garbage collector removes unwanted objects. So if any unreferenced objects are there, those will be automatically removed by the garbage collector. That is called automatic memory management. So if any unwanted objects are there, means unreferenced objects are there, those objects will be removed automatically by the garbage collector. That is the advantage here. Whereas in case of C++, if we are allocating the memory by using new means, as a programmer, we must destroy that memory. Otherwise, that memory will not be destroyed. Whereas in case of Java, there is garbage collector is there. So this garbage collector removes unwanted objects. If any unreferenced objects are there, those will be removed. If you are not using any object for longer time, that will be removed. That is automatic memory management. And next, exception handling. Java supports to exception handling feature. So exception handling means, see, so when we run the application, when we run the Java application, some errors will occur in the middle of execution. Those errors are called runtime errors. When we run the Java application, some errors may occur in the middle of execution. Okay, for example, insufficient memory is there. If insufficient memory is there, then that raises the runtime error. If memory is not available, that raises the runtime error. Okay, or otherwise, when you are trying to divide with a zero, that raises the runtime error. Okay, when array index is out of range, when array index is out of range, that raises the runtime error. In such type of situations, that raises runtime errors. These runtime errors are very dangerous, because when runtime error occurs, our application will be closed in the middle of execution. So exception means runtime error. Exception handling means the mechanism of handling runtime errors. The mechanism of handling runtime errors. The mechanism of handling runtime errors is called exception handling. So it is a process of handling runtime errors. So for example, here 100 lines code is there. Here 100 lines code is there. 100 lines code is there. Okay. So in the 50th line, so like this 100 lines code is there. 100 lines code is there. At 50th line, some runtime error is occurring. Some runtime error is occurring at 50th line. Okay. At 50th line, some runtime error is occurring. So when runtime error occur, it will not execute remaining 50 lines code. It will not execute this remaining 50 lines code. Our application will be closed here itself. So it is inconvenient to the user. User may feel irritated to use this application if the application will be terminated in the middle of execution, that he cannot continue his work. The remaining code will not get executed. Application will be closed in the middle of execution. So that's why as a programmer, we must handle the runtime errors. The mechanism of handling runtime errors is called exception handling. I will give one simple example to you. For example, assume that you have smartphone. You have a smartphone. That smartphone has 32 GB internal memory is there. No external memory is there. No supporting card is there. Only 32 GB internal memory is there in your mobile. So you used all 32 GB memory. So this 32 GB memory you used, this is completely filled with the data. This is completely filled with data like images or audio songs, movies, okay, some important documents. So that 32 GB complete data, complete memory is filled. Okay, now once again I'm repeating the example. So you have a smartphone that has 32 GB internal memory. So 32 GB internal memory, 32 GB internal memory. Okay, so that 32 GB memory filled with data like movies, audio songs, video songs, some important files, documents. So you completely used that 32 GB, no memory is there. Okay, now you are trying to take the selfie. Now 30 GB memory is already filled. By using your smartphone, you are trying to take the selfie. Okay, now can you take the selfie now? Is that image will be stored? No, that image will not be stored because memory is not sufficient. Insufficient memory is there. 30 GB memory already full. Then how can you save your photo? So that's why that gives the message as, okay, memory is full. So this memory is full message that is giving at runtime to you. So that camera app developers handled this runtime error. If memory is not available, please display this message. They handled it like this. I will give one another example to you. Okay, now I'm taking online class. Okay, with the help of go to training, I'm using it. So in the middle of session, if my network is disconnected, if network is disconnected, then automatically it displays one message to me: network disconnected. If network is re-established, again it displays message to me: network re-established. So like that, I can understand whether network is disconnected or whether network is re-established or not. So they develop it like this. Go to training, developers develop it like this. Okay, so with that I can understand network is disconnected. At runtime, I am getting the problem. So they handled it by displaying the message to me. So I can re-establish the connection and I can continue my work. So like that. So to handle the runtime errors, okay, this Java is providing many classes. That mechanism is called exception handling. So for exception handling, Java is providing many classes to us. Very, very important. Okay, in real time, exception handling is very, very important. So we can define our own exception clauses. Okay, and Java is also providing many exception clauses to handle the exceptions. Exception means runtime error. So that's why we are calling Java as the robust. Automatic memory management is there and exception handling feature is there. These features were not available in the C++. C++ supports partially to the exception handling. Okay, so now I'm stopping the session. So till robust we discussed. In the next session, I explain remaining features. Okay, now I'm stopping the session. So today we discussed these features. Okay, how many features? 6 features we discussed. Tomorrow I will explain remaining 6 features. Okay, I'm giving overview on today's class. Platform independency means Java application can run on any operating system on any microprocessor. Platform means operating system plus microprocessor. Machine independency means Java application can run on any machine. Okay, like smartphones, tabs, set-top boxes, Blu-ray DVD players, okay, routers, okay, etc. So it is the compiled and interpreted programming language. JVM has execution engine. That execution engine has compiler and interpreter. Both are there. So initially Java was interpreted language. Later they added compiler to improve the performance. And this Java is the pure object-oriented programming language because we define each and every member inside of the class. And this Java is the portable programming language because of platform independency, because of machine independency. This Java became portable. Without making any changes to the Java application, we can run on any machine, on any operating system, and on any microprocessor. And this Java is the robust programming language because here automatic memory management is there. Automatic memory management is there, and also exception handling feature is there. Because of these two reasons, we can call Java as the robust programming language. Okay, now I'm stopping the session. Okay, Kiran. Okay, now regarding today's session, if you have any doubts, you can ask. So very clearly, I explained 6 features. If you have any doubts, you can ask. Okay, no doubts. Shall I stop the session? Yes, I'm stopping the session. Okay, tomorrow I will explain remaining features of Java. Okay, thanks to all. Meet you tomorrow. Okay, Kiran, bye. Okay, I'm stopping the session. Thanks to all. Meet you tomorrow.